Hello! Yes! Woo! And welcome to our Objective 6.2 notes. Objective 6.2 says I can solve rational equations, and that, my friends, is what we're going to do today. So what I want to do to get started is some very basic rational expressions. Remember, whenever we're adding or subtracting fractions, we need common denominators. That applies when we're solving rational expressions. So 1/6 plus 2x over 5th equals 11 over 3rd. So in order to make this work, I need a common denominator for 6, 5, and 3. Let's see, 6, 5, and 3, I think 30 would be the way to go here. So I'm going to switch all these fractions to being over 30. So 1/6 would be 5/30ths. 2x over 5, well, if I multiply 5 times 6 to get 30, then I need to multiply 2 times 6 to get 12x. And then 11 over 3, I need to multiply both those by 10. And we get this. Now, here's the key. Once we have common denominators, I can multiply everything by that common denominator, and they will all divide out. And that changes everything, because now I have 5 plus 12x equals 110. All right, to solve this, just subtract by 5, so I'll get 12x equals 105. Divide by 12, divide by 12. Let's see, we can definitely take a 3 out of both of those. 105 divided by 12. Let's see, 12 is 96. 12 times 8, 96, 105. So it's going to be something over 4. 105 divided by 3. Is that 35? I believe it is. So x in this case will be 35 over 4 once that simplifies. All right. Now looking at letter B here, 3x minus 2. So this one, a little more straightforward. I have 8. That could be a good common denominator. Over 8. In order to do this, I need to multiply both my numerator and denominator by 4. 8. So 3x plus 8x. Well, remember, now that I have these in common, I can multiply by 8, get rid of the denominators. Once we have common denominators, they stop becoming an issue. 8x equals 13. And then we're just dealing with a linear. So we'll have 11x minus 2 equals 13, add 2. So 11x will equal 15, which means that x will equal 15 over 11. And there we go. That would be my solution to this problem, okay? So when we're dealing with rational expressions, there's a major idea we need to discuss, and that is excluded values. And the logic behind excluded values is that we can't divide by 0. Therefore, when we have our denominator factored, we must determine our excluded values. Excluded values are values of the variable that cause the denominator to equal 0. Now, fortunately for us, it's very easy to determine the excluded values. These are values that our variable cannot equal. To figure them out, all we need to do is set our denominator equal to 0 and solve. So, looking at some quick examples here. So, letter A, what can n not be? N cannot be 0, because if n was 0, that means my denominator would be 0. For letter B, 35n minus 15, I'd say, okay, well, whatever that is, it cannot equal 0. So that means 35n cannot equal 15. Divide by 35. 15 over 35, we can take a 5 out. So that's saying n cannot equal 3/7. For C, 56, well, our variable is not at play in there. So in this case, there's no excluded values. Now letter D, x squared plus 3x plus 2 can't be 0. So let's focus in on this one here a little bit. So that means if I factor this, x plus 2 and x plus 1, those can't equal 0. So that means x plus 2 can't be 0. X plus 1 can't be 0. So that means x cannot equal negative 2, and x cannot equal negative 1. Those are my excluded values. Now, it's important to note, these are not the answers. These aren't the solutions. These are what our solutions cannot be. So if I were to solve this and find x equals negative 2, no. That doesn't work. Okay? So let's talk about how we actually solve these in full here. So, to solve irrational equations, first we're going to find the common denominator of all the fractions, and that's important. Right? We need to be able to identify what does my denominator need to be, and then we need to make all fractions have those common denominator. Common denominator, so important when we're adding or subtracting fractions. Then we are going to eliminate the denominator. So once we have it figured out and everything has that common denominator, we can multiply both sides by the common denominator. They divide out. Then we'll solve for the variable. And very important last step, check your solutions with the excluded values. We have to make sure that those are not the same. Anytime that we get a solution that is also an excluded value, well, in that case, we would have an extraneous solution. Extraneous. Okay, so let's try a few examples together. Let's look at letter A here. My goal is to figure out what B needs to equal in order to make this a true statement. Now, looking at my denominators, I know B cannot equal 0. That would be my excluded value. Now, in order to get these so that they all have common denominators, I would need to multiply this last fraction by B over B. Then they'd all have that denominator of B squared. So I'll have B minus 1 over B squared equals B plus 4 over B squared plus B over B squared. Now, since they all have those common denominators, I can multiply both sides by B squared, and they will all divide out. Once that happens, I'm left with B minus 1, just my numerators, equals B plus 4 plus B. So that means B minus 1 equals 2B plus 4. Let's see, to get B all by itself, subtract B. So I'll get negative 5 equals B, or B equals negative 5. Fantastic. Now, here's the key. B equals negative 5. That is not my excluded value, so that's good. That checks out. If I were to plug in negative 5 up here, I would get a true statement. And that's always our goal. Now, let's see here. Oh, boy. So, looking at letter B, a little more tricky here, huh? Let's start with our excluded values. So, I'm going to start by saying n squared plus 3n minus 4 cannot be 0. So I need to factor that. That would become n plus 4 and n minus 1 cannot equal 0. Notice n plus 4 is a factor here. That same factor in there. That's going to be handy. So I'll say n cannot equal negative 4 and n cannot equal 1. That also tells me this middle fraction, the factor it's missing, is n minus 1. So I'll have 5 over n squared plus 3n. You know what? Let's write this in factored form since we already factored it. N plus 4 times n minus 1 equals 1 over n plus 4. And then I'm going to multiply this one, n minus 1 over n minus 1. That way they have the common denominator as well. Plus 1 over n plus 4 times n minus 1. Fantastic. So, now that these all have common denominators, I can multiply both sides of the equation by n plus 4 times n minus 1. Again, both sides get multiplied so that they stay equal, of course. And that forces all of them to divide out. Now, what am I left with? I'm left with 5 equals 1 times n minus 1 plus 1. So that means 5 equals n minus 1 plus 1. Well, negative 1 plus 1 is just 0, which means that n equals 5. Now, the important thing, check, is that one of my excluded values? No. No, it is not. Therefore, we can be pretty confident that n equals 5. If you're ever in doubt, also, you can totally plug it back into that equation. See if it works. It should if we did everything right. Let's go over here. Oh boy. All right, let's look at letter C here. This will be a fun one. 5v, v minus 5 minus, okay. Common denominators to start with. So I see right away here, 3v minus 6 is a denominator that we have here. So that is 3v minus 2, right? So I'm going to have v minus 5 over 3 times v minus 2 minus v minus 6 over 3 times v minus 2 equals 1 over, well, v squared plus 2v minus 8 would be v plus 4 times v minus 2. So let's look at the factors in our denominators, because we know we can't have values that equal those. So that means v cannot equal negative 4. We also have v minus 2. We know v cannot equal 2 then. So there are our excluded values. Now, in order to get common denominators, I need to multiply, oh boy, this fraction by 3 over 3 to get the 3 in there, right? Need to have that. And then I need to multiply the two fractions on the left by v plus 4 so that those are included. So let's write all this out here. This will be fun. V minus 5 over 3 times v minus 2 times v plus 4 over v plus 4 minus v minus 6 over 3 times v minus 2 times v plus 4 over v plus 4 equals, and then I'm going to say we already multiplied that out, 3 times v minus 2 times v plus 4. So here's the good news. Now that we've done all this, we can multiply by our common denominators. We are left with just our numerators. So we will have v minus 5 times v plus 4 minus v minus 6 times v plus 4 equals 3. Whew. All right. Well, distribute, multiply this out here. I'll get v squared minus v minus 20. And then I'm going to subtract from that v squared minus 2v minus 24 equals 3. So subtracting v squared minus v squared becomes 0. Negative v minus negative 2v would become v. Negative 20 minus negative 24 would become positive 4. And that equals 3. V plus 4 equals 3. Subtract 4 from both sides, and I find v to equal negative 1. Now here's the key. Is negative 1 one of our excluded values? No, it is not. Therefore, we can say absolutely that is our solution. All right, one more problem to do. One more, last one. Hopefully we're feeling pretty good with these. This one's going to be a fun one. Okay, here we go. So, starts easy. N cannot equal 0. Right? That's the only denominator that we're really at play here. So my excluded value, n cannot be 0. I know 5n is going to have to be my common denominator. So I'm going to start here. N squared plus 6n plus 8 over 5n equals 5n times n would be 5n squared. 5n times 3 would be 15n. And 5 would be all I need to multiply that last fraction by to give me 5n in my denominator. So with that being said, let's multiply both sides by 5n, both sides by 5n. Those denominators will all divide out, and that means I'm left with n squared plus 6n plus 8 equals 5n squared plus 15n minus 5. Whew. All right, well, what type of an equation are we dealing with now? A quadratic. How do we solve a quadratic? Let's set it equal to 0. So I'm going to subtract n squared minus 6n minus 8. I'm going to subtract those on both sides. When I do that, I get 0 equals 4n squared plus 9n minus 13. Wow. Now, is that factorable? I don't know. I don't know off the top of my head, and if I don't know off the top of my head, I'm leaning towards quadratic formula for this one. So let's say x equals the opposite of 9 plus or minus the square root of b squared minus 4 times a, which is 4, times c, negative 13, all over 2 times a, which is 4. So x will equal negative 9 plus or minus square root of 9 squared is 81. Negative 4 times 4 is 16. Now let's see here. I might have to pull up the calculator, huh? All right, let's see if it'll appear for us today. So if I want to figure out what this is here, I'm going to need to say negative 4 times 4 times negative 13. So that becomes 16 times 13. Now let's close out of here. 16 times 13, 208. 81 plus 208 divided by 8. So x equals negative 9 plus or minus square root of, let's see, that'll give me 289 divided by 8. What do we think? Is 289 a perfect square? Let's find out. Second, square root 289. What do you know it is? It's 17. So that means x equals negative 9 plus or minus 17 over 8. Now remember, that means I have two values I need to check on here, right? So I'll say x equals negative 9 minus 17 over 8, or x equals negative 9 plus 17 over 8. Now negative 9 plus 17 is 8. So this would mean x equals 8 divided by 8, which is 1. Negative 9 minus 17 would be negative 26. Negative 26 over 8. Let's see, I can divide both of those by 2. Negative 13 over 4. So we find x equals 1 or x equals negative 13 over 4. Now remember, important, check our excluded values. What was our excluded value for this one? Just that n cannot equal 0. Therefore, 1 and negative 13 over 4 checks out just fine. And there we have it. That's how we can solve rational equations. It's a lot, isn't it? We got to be sure that we follow our steps, go through a lot of details. Again, fractions, fractions, fractions. Tons of fractions in this one. Make sure we're confident working with fractions. If you have any questions, please don't hesitate to ask. Feel free to get started on those sample problems. I have a feeling seeing more of these will definitely be helpful. This is Mr. Carter signing off. I'll see you next time.